Welcome back to All This Math. This is Professor Parker, and today I got my Kwame Ture pen right here. If you're not familiar with Kwame Ture, formerly known as Stokely Carmichael, go look him up. Do some research on that brother. All right. Today I want to talk about something that's very important in mathematics. All right. It's a little skill, a little activity that you do when you might be multiplying two fractions. All right. It's called cross canceling. Cross canceling. And I wanted to do a video specifically on how to cross cancel because a lot of times, over the years I've taught students or I've been tutoring students more recently or over the years. And, we're just, multiplying fractions and or dividing fractions where you do the keep, change, flip thing. And then it's time to multiply the two fractions. And, many, many years ago, I was taught how to cross cancel. So that's something that's just like second nature to me. But what I realized is that a lot of people haven't been taught how to cross cancel. So I wanted to take time out to get real specific and focus in on how to cross cancel. Because cross canceling is very beneficial because what it does is it enables us to change the fraction while we maintain the same value of the fraction, but we change the numbers in the fraction to much smaller numbers. And the good thing about changing your numbers to smaller numbers in a math problem is that once you do that, the math becomes easier to manipulate and it becomes easier to manage because your numbers are smaller. I mean, check this out right here. Like, who really wants to sit up here and try to multiply 32 times 18 without a calculator? Like, who really got time for that? Who really wants to try to do that? I mean, we could do it, right? But if you could avoid doing that, why not avoid it, right? And what cross canceling does in certain scenarios and situations is it enables you to have smaller numbers. So therefore, you won't have to multiply big crazy numbers like 32 and 18. Oh, look at these. Like, look at these denominators right here. Like, you got 72 and 64, right? Once you cross cancel, we won't have to worry about that. All right? Now, I talked a little bit, and I just told you why we do it, right? That's important. We need to know why we cross cancel. Like, why is it beneficial? Like, why should I know how to do this? Why should I take the time to watch this video and learn how to do this skill, Professor Parker? I already told you that. Now I'm going to tell you how to do it. All right? So I got a couple of examples up here of multiplication with two fractions. All right. Now, cross canceling. When you hear cross cancel, it's not cross multiplication. That's something different, right? We still are dealing with diagonals, but we're not multiplying diagonal. We're canceling diagonal. All right. That's different. So if you're in elementary school watching this, or you remember being in elementary school, my daughter used to talk about, sitting when it was reading time, they would have to sit on the carpet and fold their legs and do crisscross applesauce. That's what all the students would have to do. So you're doing diagonal, right? So your legs will be folded diagonally, right, across each other. So when you're cross canceling, you look at the numbers that are diagonal from each other. So the numerator in the first fraction and the denominator in the second fraction, all right? And you look at the numerator in the second fraction and the denominator in the first fraction. And what you want to ask yourself is, what is the GCF? All right, that's the question you want to ask yourself of those two numbers, those numbers that are diagonal from each other. So you want to say, what is the GCF? Now, if you don't know what the acronym GCF stands for, I'm going to tell you. It stands for greatest common factor. Greatest common factor, which basically just means the biggest number out of those two numbers, right? Or it could be sometimes you could have a group of 3 or 4 numbers, right? But it means the biggest number that can multiply evenly into both of those numbers. Into both of those numbers. So I'm gonna show this to you, and it'll make more sense once I list out the factors. So let's deal with this diagonal first, right? I got a 4 and an 8. So let me list all the factors of 4, right? Now over time, this is something it's not gonna take this long for you because over time you can be doing this mentally, right? Especially if you know your multiplication facts. I can't stress that enough. I say that all the time. Memorize the multiplication table. Memorize the multiplication facts. That's going to make things a lot easier. All right? So I write down 4, and the factors of 4 are 1, 2, and 4. Now, why are those factors of 4? Because I know that 1 times 4 is 4. I know that 2 times 2 is 4. And I know that 4 times 1 is 4. So a factor is a number that can be multiplied into another number, right? So the factors of 4 are all the numbers that can be multiplied into 4. All right? Because like I said, 1 times 4 is 4, 2 times 2 is 4, and 4 times 1 is 4. Now I do the same thing for 8. I'm going to list out the factors of 8. There are 1, 2, 4, and 8. Now, why are those the factors? Because 1 times 8 is 8, 2 times 4 is 8, 4 times 2 is 8, and 8 times 1 is 8. So all 4 of these numbers multiply into 8 evenly. That's the key, evenly. Because realistically, there's an infinite number of numbers that multiply into 8. There's an infinite number of numbers that multiply into 4. Billions and trillions, and more than that. Realistically, when you start to get into all the decimals, but decimals are not whole numbers. So when we talk about factors, we're talking about whole numbers. No decimals, no fractions. We're talking about whole numbers. That's what we're talking about. All right? Now, the greatest common factor is the biggest number that's in both lists. The greatest common factor, right? Not just the common factor, because you notice how 1 is in both lists, 2 is in both lists, and 4 is in both lists. 8 is only in this list, right? Because 8 can't multiply into 4. 8, you can't multiply 8 by a whole number and get 4. You can multiply 8 by 0.5 or by 1/2 and get 4, right? But 8 is not a factor of 4. The biggest number that's in both lists is 4. So that means that 4 is the greatest common factor. 4 is the greatest common factor. All right? Now, what do I do with the GCF? Now that I found the GCF, now I got to do something with it. What I do with it is I divide each of those numbers by the GCF. So I do this. I do 4 divided by 4. I do 8 divided by 4. And since 4 divided by 4 is 1, this 4 is going to turn into a 1. Draw a slash through it and put a 1 right there. And since 8 divided by 4 is 2, this 8 turns into a 2. Boom. So now that 4 turned into a 1 and that 8 turned into a 2. We just cross cancel. We just cross cancel. And now what's going to happen is now I'm multiplying smaller numbers. Plus, another thing that's beneficial of cross canceling is this. If you didn't cross cancel and you could have, and you multiply straight across horizontally, once you get your answer, you're going to have to reduce anyway. So it's like a now or later type thing. You're going to have to reduce some kind of way. Either you're going to reduce up front and then multiply, or you're going to have to multiply up front and then reduce later. So you can't escape having to reduce. You're going to have to reduce. And a lot of times, it's easier to just do your reduction or your simplification up front by cross canceling, right, than by doing it later. You'll see that. Now look at the next diagonal. I got a 9 and a 3, or a 3 and a 9. So I want to figure out what's the greatest common factor of 9 and 3. So I'm going to write 9 down right here, and I'm going to list the factors of 9. So 9 is not a prime number. It's composite. It's not a prime number. It's a composite. A prime number is a number that only has 2 factors, 1 and itself, right? A composite is a number that has more than 2 factors. Basically, that's all it is. And some teachers will give you a test, and it'll be a trick question. And they'll say, well, is 1 a prime number or a composite number? You know it's not a composite number, but a lot of people think 1 is a prime number, when in fact, 1 is in a class all by itself. 1 is not even a prime number, because 1 only has 1 factor. By definition, prime numbers have 2 factors, 1 and itself. 1 only has 1 factor, though. Keep that in mind. All right, back to the 9. The factors of 9 are 1, 3, and 9. Those are the factors of 9. 1 times 9 gives you 9. 3 times 3 gives you 9. 9 times 1 gives you 9. Those are the factors of 9. 9 only has 3 factors. Now we do the same thing for 3. Now 3 happens to be a prime number. 3 only has 2 factors, 1 and itself. So we got 3 and we got 1. Now we're looking for the GCF again. What's the biggest number that's in both lists? The biggest number that's in both lists is 3. Now notice that 1 is in both lists, but 1 is not the biggest number. Plus, if 1 is your greatest common factor, then that means that there is no greatest you can't cross cancel, basically. That's what that means. If 1 is your GCF, that means you can't cross cancel, because what you end up doing is dividing by 1. And what happens when you divide by 1? You get the same number. That's like the identity property of division. you end up with the same number anyway. All right? So 3 is my GCF. So what I'm going to do is I'm going to do divided by 3. That equals 1. That cancels out, turns into a 1. I'm going to do 9 divided by 3. That equals 3. That cancels out, turns into a 3. Boom. Now we can multiply. Now it's time to multiply, right? We multiply horizontally. Horizontal means left to right, as opposed to vertical, which means up and down, right? Vertical, up and down, horizontal, left to right. So now this is not a 4 no more. So I'm not multiplying 4 times 3. That's why I put the slashes through them. That 4 turned into a 1. That 3 turned into a 1. So now I'm doing 1 times 1. That gives me 1. Now this 9 turned into a 3. This 8 turned into a 2. So now I'm doing 3 times 2. Boom, 1/6. And that is my answer. And it's easier to do the math because I got smaller numbers. So when you can get smaller numbers, get your smaller numbers. All right, let's take a look at this example. These numbers are huge. These numbers are huge. All right, but check this out. We can cross cancel. So I see 32 and I see 64. 32 and 64. All right, 32 and 64. Now, I'm not going to list out every factor of 32 and of 64. Okay, I'm not going to do that. You can do that, right, on your own. You can list out the factors, right? But I kind of just want to, the reason I'm not going to go into detail on and list out all the factors on this example is because I really just want to drive home the benefit of cross-canceling in this particular video. So I'm going to just tell you that the greatest common factor of 32 and 64 is 32. So that means I'm going to divide this by 32, and I'm going to divide this by 32. And 32 divided by 32 is 1. So this 32 turns into a 1. 64 divided by 32 is 2. So the 64 turns into a 2. Now, go to the other diagonal, 18 and 72. We need to know a little bit about numbers. 18 and 72 also have a greatest common factor, 18. 18 is the greatest common factor of these two. So I do 18 divided by 18, and I do 72 divided by 18. Now, 18 divided by 18 is 1. 72 divided by, let me try that again. 72 divided by 18 is 4. So now you see how small these numbers are? Think about how large the numbers were before, and look how small they are now. So how much more simple is your math going to be now than it was before? See, we got to understand something. Like a lot of times you learn things in a math class, and you think, oh, this teacher's trying to punish me. Why we got to do all this? Why is it so complicated? This is a gift. If you didn't know how to cross cancel, you would really have to do 32 times 18. And there will be problems where you are not allowed to use calculators sometimes. So you might say, oh, it don't matter. I got a calculator for that. It's cool. I'll do 32 times 18. Sometimes you won't be allowed to use a calculator. Like if it's a standardized test or something, or it might just be a test your teacher's giving you. And they may not allow you to use a calculator, right? So if you know how to cross cancel, then things get easier. So now you got 1 times 1, which is 1 because we're multiplying horizontally. And we got 4 times 2, which is 8. And that's my answer. All right? And we just cross cancel. All right? Now let's slide down here. Let's check out this last example before I end this video. All right? So I got 3/5 times 7/12. All right? In both of these examples, we were able to cross cancel in both directions. That's not always going to happen. Sometimes you won't be able to cross cancel at all. Sometimes you'll only be able to cross cancel on one diagonal. Now, I got 3 and 12. Now, with 3 and 12, those can cross cancel because 3 and 12 have a greatest common factor of 3 because 3 multiplies into 3 and 3 also multiplies into 12. So I do my 3 divided by 3. The 3 turns into a 1. And I'm going to do 12 divided by 3. The 12 turns into a 4. Right? Now, look at the other diagonal. I got a 5 and a 7. The greatest common factor of 5 and 7 is 1. It's 1. So we can't really do nothing with that. So we can't change the 5 to anything. I mean, if you want to, you could do 5 divided by 1. You're still going to have 5. You could do 7 divided by 1. You're still going to have 7. Nothing changes. All right? So now we multiply straight across. 1 times 7 is 7. 5 times 4 is 20. And that's our final answer. 7/20. So this is just another example where in one of the diagonals we were able to cross cancel, but in the other diagonal we weren't. So that's just something that I just wanted to get into. I wanted to get into like just showing people how to cross cancel. Cross canceling is a great skill, and it just helps you to simplify multiplying fractions. All right, so I hope that helped, and share the video with somebody. If you haven't subscribed to the page already, please subscribe to the page and tell somebody about the page. Tell them what we're doing here, all this math. All right, and as always, do remember, there's all this math all around you. Peace.